Yes. Welcome to Electric Circuits Lab. Today we are going to discuss our next experiment, verification of Kirchhoff's voltage law. Okay. This is our circuit diagram. In this circuit, we are going to have three resistors and one input voltage source. Then we are going to measure the voltage drop across individual resistors, followed by we are going to verify the KVL law. Okay, Kirchhoff's voltage law. So what we are going to do means, as per the procedure, we are going to vary the input voltage in steps of 5 up to 30 volt. We will do it in our laboratory experiment. But here we will give some input voltage straight away in the question paper. So what you have to do, you need to set the particular input voltage, then you need to find the corresponding voltage drop in the individual resistors. Okay, then you need to verify the KVL. You need to tabulate the values in the corresponding column. Then you need to verify. How you need to verify? You need to add all the voltage drops. This addition value must be equal to your input voltage. That is nothing but the sum of potential rise must be equal to the sum of the potential drop. Okay. Very first thing, we will start do the simulation. Before that, let me take the input voltage and resistor values. In your question paper, we will give some input voltage. Say example, the input voltage 20 volt. Okay, then value of the resistors, say example, R1 1 kilo ohm, R2 2 kilo ohm, okay, R3 3 kilo ohm. So these things will be given in our question paper. So first we need to draw the circuit diagram. Then you need to connect the voltmeter across individual resistor. Then we need to start give the connection. After that you need to tabulate the readings. The circuit diagram is very simple. I need to connect my voltage source and three resistors in series combination. Okay. First we will go to Tinkercad software. For that, first I need to click join now. Then I need to click students, join a class. Then I need to type my class code. Okay. During examination, we will provide the class code. So class code you need to type first. Then click go to my class. Then click join with nickname. Here you need to type the nickname given by the faculty. Okay. AC127. Let me put my nickname here, then click that's me. That's all. So now you know very well, you need to click circuits, then click create new circuits. Then click create new circuits to get the new circuit diagram. Then as usual, you need to give the name of the project as your roll number. Okay, let me put the sample roll number here. Then what we need to do, click the drop down box and select all. So what are the components required for our experiment? What are the components we require? One voltage source, three resistors and three voltmeters. Okay. Three resistors, three voltmeters and one regulated power supply. Then obviously we need a breadboard to connect the components. Let me take the breadboard. Okay. Yes. Then followed by I need a power supply, then one multimeter. That's all. Let me arrange the components in a proper way. So this is my regulated power supply. then this is my multimeter, then this is resistor. I need three resistors, therefore I am going to click Control C and Control V two times. Okay, Control C and Control V two times. That's all. Now I got three resistors. Again I need 3 voltmeters. Control C, Control V. Then Control C, Control V. Okay, now I got 3 voltmeters. Okay, now very first I am going to power the breadboard. So from the positive terminal to the positive line of my breadboard. So I am going to change the color as red for the positive wire. Then negative, from the negative terminal I am going to power the breadboard negative rail. Okay, so successfully we have powered the breadboard. Then now I am going to connect all the resistors in series. Then I need to connect the series combination of the resistors with the input voltage source. Before that, what are the resistor values? R1 is 1 kilo ohm, R2 is 2 kilo ohm, R3 is 3 kilo ohm. So input voltage is the 20 volt. So click the resistor, then you will find one menu bar. There you can select the resistor value. So R1 is 1 kilo ohm. It's very simple. I no need to change the value. The second one is R2 is the 2 kilo ohm. Click 2 kilo ohm. Okay, then R3 is 3 kilo ohm. Okay, then now I am going to connect all the resistors, three resistors in a series combination. For that I want to rotate the resistor first of all. Simply click this rotate icon, the resistor will rotate. Take the resistor and keep it in the breadboard. Okay, then second resistor R2 I am going to rotate. Yes, then third resistor. That's all. Okay, now we have connected all three resistors in series combination. Now we need to connect the series combination in parallel with our power supply. So the first R1, one end of the R1 resistor, I am going to connect it to the positive terminal of my input source. That's all. Change it to red color. Then the last resistor R3, the end terminal, I am going to connect it to the negative terminal of the power supply. That's all. Check once the circuit diagram. R1, R2, R3, all are connected in series. Then the series combination is connected across our input voltage source. Now we need to connect the voltmeter across individual resistors. So how to connect? Bring the first voltmeter, take the one connecting wire from the positive terminal. Okay, connecting wire from the positive terminal, connect it in the first terminal or starting terminal of the R1. Okay, so the current entering terminal must be the positive, therefore I'm going to connect it in the positive terminal of the voltmeter. Okay, then other end of the voltmeter I'm going to connect it in the end terminal of the resistor. Okay, starting end and finishing end, black. Is it okay? Now we have connected the voltmeter across the R1 resistor. Okay, across the R1 resistor. Similarly, we need to connect the second voltmeter across the R2 resistor. Okay. Yes. So positive terminal. So I'm going to change the color wire as a red color. Then from the negative terminal, I need to connect it to the other end of the R2 resistor. That's all. Change it into black. Then third voltmeter. Okay, third voltmeter. Again, the positive terminal need to be connected to the current entering terminal of the R3 resistor. This should be red color. Then again from the negative terminal connected to the other end of the R3 resistor. That's all. Okay, so R1, R2, R3 all are connected in series. The combination is connected across the power supply. Then voltmeters are connected across individual resistors. Now, how to start the simulation? Click the play button. That's all. But the default input voltage it shows as a 5 volt. But as per our question paper, we need to give 20 volt as an input supply. So go there and change the voltage as 20 volt. That's all. Now we need to note down the corresponding voltmeter readings. V1 is 3.3 volt, V2 is 6.67, V3 is 10 volt. Okay, now we need to tabulate those readings. So serial number, this is the first reading. Input voltage, as per the question, it is 20 volt. Then what is the voltage measured across the first voltmeter? It is 3.33 volt. What is voltage drop across second voltmeter? It is 6.67. What is the voltage across the third voltmeter? Or the reading of the third voltmeter is 10 volt. That's all. Now we need to verify KVL. How to verify? In the third tabulation column, we need to add all the voltage drop across the individual resistors. Okay, that is V1, V2, and V3. So if you add 3.33 plus 6.67 plus 10, the total voltage will be 20 volt. So V1 plus V2 plus V3 is equal to 20. Okay, if you add these three values, you will get V1 plus V2 is equal to 20 volt. Now you need to write the statement as V input voltage is equal to the sum of the voltage drop across the individual resistors V1 plus V2 plus V3. So input voltage is 20 volt. If you add all the voltage drops, you are getting again 20 volt. Therefore, Kirchhoff's voltage law is verified. Kirchhoff's voltage law is verified. Okay, that's all. I will repeat the procedure once again. You need to draw the circuit diagram as per the question paper. Then you need to do the simulation in the Tinkercad software. Then you need to set the input voltage as given in the question paper. Then you need to note down the individual voltage drops. At last, you need to tabulate the readings. Then you need to verify the law. Okay, that's all. Thank you very much. If you have any doubt, please contact.